Good morning, afternoon, or evening. Today's lesson should be pretty quick. We're going to talk about simplifying square roots. All right. Another name for a square root is a radical. All right. For those of you who may have been born or been to the West Coast, a radical is a cool thing. Here it's something that is math oriented, and we're going to get to learn it. So this sign here, we know of it as the square root sign. But it is also known as a radical sign. This number underneath the radical sign is referred to as the radicand. So if you ever hear me use those terms, that's what they mean. I'm not concerned if you guys memorize that, but hopefully you guys understand that those words are interchangeable. When working with square roots, the most common square roots are perfect squares. Right? A perfect square is the result of squaring an integer. Another way to think of it is if you take the square root of a number and you get a whole number, then it is a perfect square. For example, 4 is a perfect square because the square root of 4 gives you 2, a whole number. So it may be helpful to remember these perfect squares. So 1, 4, 9, 16, 25, 36. Does anybody see the pattern there? Hopefully you do. So if I take the square root of these numbers, I'm going to get 1, 2, 3, 4, 5, ... Right? So a perfect square is a result of squaring an integer. Okay? Or it could be really -1, -2, because when we square a negative number, a negative times a negative is a positive, so we're always going to have a positive square. So perfect squares are the result of squaring an integer. Along with getting to I don't want to say memorize, but maybe you are going to memorize the perfect squares. Some of them you probably already have to memory, other ones by using more frequently you'll take to memory. The other thing we're going to do right now with square roots is estimating them. So when you're given a square root that's not a perfect square, the easiest way to estimate it would be to see what square root fits on either side. So in this case we have the square root of 300. So if we know our perfect squares, we know that 324 is a perfect square above it, and 289 is a perfect square below it. So which one is 300 closest to? Well, 300 is a little closer to the square root of 289. And we know that the square root of 289 is 17. So what we're going to say is, and I'm going to use this instead of equals, this is called approximately equal to, or estimated. The square root of 300 is approximately equal to 17. Because when we're estimating, we're only looking for an approximate value. So it's actually going to be 17 point something. But since it's closer to 289 than 324, we're going to round down and estimate it to 17. You'll get a little more practice with this with the questions after the lesson, and you'll check your understanding.